Okay, let's go on to the homework exercise 2. We have data that represents several hotels, and these are overall rankings for those hotels, and they're also being assessed on the dimensions of comfort, amenities, and in-house dining. So what we're looking at then is this company. They have a magazine devoted to upscale vacations and accommodations, and they published this in their Reader's Choice list of the top 20 independent beachfront boutique hotels in the world. So that's what you're seeing here. The data shown are the scores received by these hotels based on the results from their survey. Each score represents the percentage of respondents who rated a hotel as excellent or very good in one of 3 dimensions. 3 criteria: comfort, amenities, and in-house dining. An overall score was also reported and used to rank the hotels. The highest ranked hotel, the Murray Beach Odyssey, has an overall score of 94.3 here, the highest component of which is 97.7 for in-house dining. All right, so determine the estimated multiple linear regression equation that can be used to predict the overall scores. So this is what we're trying to predict. This will be the dependent variable, given the scores for comfort, amenities, and in-house dining. So conditioned on these 3 independent variables. So these will be X. Okay, so we'll do that first. All right, here we go. So same as before, got to go to data. Go to data analysis, regression, say okay. All right, I have to do some editing here. So get rid of that. This is your Y range, so grab that whole thing. Okay, then the X range, get rid of that. Highlight these 3. So you got 3 independent variables, multiple regression. Single linear regression is just 1 independent variable. Multiple linear regression has multiple independent variables, so multiple X's. Okay, so we want that to go, let's find a spot for that right there, would be good. And we want to get the residual plots, and I think that's it, we're ready. All right, so let's rearrange these residual plots, and then we'll look at the data. So there's 3. Here's 2, and here's 1. Okay. So R squared, let's highlight a couple things. About 75% of this regression is being explained by these 3 dimensions criteria. Okay, down here, these are your coefficients that will make up the equation that you're going to develop for this model that you've proposed. And here's your p-values that you want to look at. Okay, so let's make sure we're answering questions. Determine the estimated multiple linear regression equation. So we got to do that first. We're going to type out an equation here, and we can use that to predict the overall score given the scores for these 3 things. So the equation is based on the coefficients. Let me slide that. I got to slide these down just a little bit more because I want to type it in right there. Good. Okay, so right here, the equation is y, actually it's little y, equals 35.6967. Again, I'll go 4 decimal places, plus 0.1093x1 plus 0.2443x2 plus 0.2474x3. Okay, so that's your equation. Let's highlight that. So that stands out for us. So that was part A. And then part B, use the t-test to determine the significance of each independent variable. what is the conclusion for each test at the 0.01 level of significance? All right, so t-test, t-stat is right there. And we can also use the p-value because you know the p-value already from last week is based on the t-stat. All right, so the intercept at the 1% level is just barely not clearing it. So it's almost to the point where we can reject it, but not quite. However, don't get hung up on that. The intercept is generally just a number that's extrapolated from the regression. We would never have a zero value. So if we did a scatter plot, we'd never have a zero value in which we would assess the intercept. So it's not relevant anyway. It's just a number that actually connects up with the y-axis. This p-value is not significant either. So we can't reject the hypothesis that this is significantly different than zero. Okay, so this one's not holding up. This one is. This one passes the test. That's scientific notation. If you want to convert that, you can do that, right? It's really small number is what you see there. I want to show that. That's good. Good, good. Oops. All right, so this one is holding up this number. Variable 2, which is amenities, matters, is what that's saying. Okay, it has a linear relationship with this overall score. So there's a connection between amenities and the overall score that you see. And the same thing with in-house dining. That one held up, right? That one held up. So this is a significant variable in explaining the overall score. So that's the t-test. How do you use the t-test? Okay, so the ones that held up are these two, right? These two. And notice, and this one's super close, right? Notice that using a 99% confidence interval, our critical value is 2.58. Right, so these are well above that. Right, so that gives you support for rejecting the null hypothesis. Okay, whereas this is not, and this is just super close. And we're super close here. And like I said, it's not that important anyway for this because it's just an extrapolated number. It's these variables we're interested in. We want to know whether or not these variables, these things here, have an impact on the overall score. And so it's these things that we want to be significant. All right, so if you look at these plots, make sure I'm not getting ahead of myself. So that was A. B, we did the t-test, was the conclusion for each test at the 1% level. You want to, let's look at my write-up for that. Okay, oh, there's the spot for the equation. So if you want, you can just cut that and slip it down there. There we go. Okay, perfect. All right, so B, before performing any of the hypothesis tests, we check the conditions necessary for valid inference. The Excel plots of the residuals and comfort amenities and in-house dining are above. So we're looking for problems with these based on those assumptions. So the mean is 0. You say yes, okay, okay. The variances are roughly the same. Yes, I would say yes, they're roughly the same. And trying to remember what the third one was. Be concentrated around 0. Be concentrated around 0. And I definitely I'm seeing that, right? So there's some clustering around 0, clustering around 0, clustering around 0. So I don't see any violations of the conditions that would lead me to not depend on these p-values. So in other words, they appear to be independent, separate variables in describing what's happening with the total score. All right, so then the p-value associated with the estimated regression parameter B1, that's the first one. That's the one we said didn't make it, right? That's this one. We said didn't make it, right? We can't reject that that's significantly different. It's greater than 0.1, so we cannot reject the hypothesis. We conclude there is not a relationship between the score on comfort and the overall score. Okay, so this is not a good variable for describing the overall score. The second one, though, was the amenities, and that one was significant. And so we can reject the hypothesis that it's different than 0, right? So it is different than 0. It's a predictor, has a linear relationship. So there is a relationship between amenities and the overall score at that level. And then the last one, B3, is also going to be allow us to reject the hypothesis. Significant, meaning that the value that we see there as a coefficient is different than 0. There is a relationship between the score on in-house dining and the overall score. So if ratings for comfort, amenities, and in-house dining are related to overall score, the relationships are expected to be positive. The results are consistent with expectations for all 3 relationships. Okay, so that's part B. Remove all independent variables that are not significant. So that'd be comfort. Comfort was the only one. Remove it from the estimated regression equation. What's your recommended estimated regression equation? So let's do it again. Except this time we're going to eliminate comfort. So we go to data, data analysis, go to regression. All right, we're going to change our X variables. The Y range is fine, 18 through 37 is perfect. The X variables, I want to change the D to an E and only pick up E and F, right? Okay, we got to pick a new place to put it too. So I want it right here. Okay. Okay, here we go. Now you'll notice when you put that down there, those graphs hung up here. There they are. So we got to drag them down, right? If I can cut them and paste, let's try that. Otherwise, we'll just drag them down. Yep, cut. Okay, and I want to paste it right here. Yay, okay. There it is. Cut. I'm going to rearrange those. I want 1 on the top and 2 on the bottom. There we go. Nice. Okay, let's highlight some of the important things. So look, we didn't lose a lot of power. Let's address this first. We didn't lose a lot of power. Up here we had 75 roughly % of the regression was explained by those 3 variables. By getting rid of the first one, we didn't lose a lot of power, and that's good. Right? You don't want to lose power. You want to have a model that has strong coefficient of determination, as close to 1 as possible, right? It's the best regression you can have, because R squared of 1 means that every data point is right on the line. Okay, so there are 0 residuals, right? All residuals would be 0 if all the points are on the line. All right, so if we look at our coefficients here, that's going to drive what we have for an equation. And if we also look at our p-values, so now look, now they're all significant, every one of them. All these t-stats are greater than 2.58, which is the critical value for 99% confidence interval. Okay, so for the equation, we would say, there they are right there, y is equal to 45.1461, again, I'll go out 4 decimal places. And these are all positive, plus 0.2526x1 plus 0.2483x2. Okay? Okay. So let's see. I'll review the Excel plots of the residuals, that's these. And the 2 independent variables that follow show no dramatic departures from the conditions necessary for valid inference and regression. We can proceed. Meaning that those 3 conditions we talked about earlier haven't been violated here, right? So the variances are fairly consistent across the data points. They cluster around 0. There doesn't seem to be any strange patterns that are visible where you've got, you know, some cluster up here and then some cluster down here and some cluster up here. So you have clearly independent data points, independent residuals. Okay, this one's especially looks independent, very random. And you want as much randomness as possible without any pattern showing up. All right, so we'll go ahead then. A p-value associated with the regression estimate parameter B1, so that's variable 1. B1 is variable 1, which now corresponds to amenities, is 1.32, etc. That number right there. because this p-value is less than 1%, so remember when you see that E, that scientific notation, that's a really small number. We reject the hypothesis that B1 is 0. And that's what we want to be able to do, because we want to be able to say these variables have an influence, right, on what happens with the total overall score. We want to find a relationship. Okay, so there is a relationship here, right, because this variable isn't 0. It has an influence. So if you put an X variable in there, you're going to get an impact because the coefficient on it, the slope, is positive or negative, whatever it is. Same with the second one. That is, look, really small, less than 1. So we'd say that that value is significant, significantly different than 0, and that there is a relationship between the score on in-house dining and the overall score. Okay, and then for this, like I said earlier, yeah, this one's now statistically significant, but not all that important. Right? It's not going to be valuable to us in terms of driving decisions that we're going to make. And it's not what we're looking to discover anyways. What we want to discover is whether or not these variables that we have in our model, so we've just looked at these two variables, whether they have an impact on overall. So is there a conditional relationship between them? Okay. Okay, let's wrap it up. So for this multiple linear regression model, the overall regression relationship is significant and the estimated regression coefficients, B1, B2, are significant and consistent with what would be expected. Furthermore, the model has a coefficient of determination of 73.87. The model with all 3 independent variables from part A has a multiple coefficient of determination of 0.7498. So this model explains little more than 1% more of variation in overall ratings in the sample than the model that includes only the independent variables, amenities, and in-house dining. That is, removing comfort resulted in very small loss of power, right? So the simpler regression model seems to be preferable. It's a stronger model. Okay, we can count on these variables having a linear relationship and having some predictable quality to them. Okay, so remember when you save your homework, so here's the directions, save the file on the first homework tab. So this purple tab will be amazing. So when I open it, and make sure it's at the top, so I can start at the top. When I open it, it opens right here. And then in terms of your name, last name, first name, homework lesson 13 will work beautifully. Okay, so you click on this, you hit save, and away you go. You're all done. Okay, upload the assignment.